Hey Ramblers, this video is going to cover section 5.4 in our textbook, which relates to polygons and specifically four-sided polygons. So we'll learn the definition of what a polygon is. We'll look at a couple things that aren't polygons. We'll just look at diagonals, and then we're going to focus on four-sided polygons or quadrilaterals. It's really important that you take good notes on this video. So you're going to want to copy the layout I have of how I organized all the names of the four-sided polygons, because if you can look at how they relate to each other visually, then hopefully it'll help you as you start to memorize the polygon's properties, which is something that comes up next. This is a difficult chapter, a lot of memorization, so please take careful notes, pause when you need to, and keep up with the homework. Okay, hope this helps. Okay, four-sided polygons is the name of the chapter, but it deals more generally with the term polygons. And polygons are kind of closed figures, and they have several characteristics that we'll cover here in a minute. But a polygon, in the book we refer to this several times, is a plane figure. And what that means is that it can exist on a single plane, like the plane of the chalkboard or the plane of your desk. Something that couldn't is a cube or a sphere or any kind of a prism or a pyramid. Those would not be plane figures, but polygons are. Polygons are closed figures, which means that they all of the sides intersect. All the sides of a polygon are segments, so we don't have any sides that are rounded or arches or anything like that. The sides intersect only at the endpoints or the vertices. So this pentagon here, PQRST, all the sides intersect at the vertices. But this figure down here, whatever it is, because it's certainly not a polygon, has two sides that intersect at vertices, but they also intersect each other in between. So those would not connect. This would be an example of non-consecutive sides intersecting. Okay, the convention for naming polygons is to choose any vertex and move in a clockwise or counterclockwise direction. So I could call this pentagon RSTPQ, or I could call it RQPTS. It would be just as well to call it TSRQP. It doesn't matter so long as you don't do something like call it QTRSP and just a random sequencing of the vertices. Okay, all of the polygons that we will study in this book will be convex, meaning that each of their interior angles is less than 180. This polygon on the left side is convex. Each of the interior angles at W, X, Y, and Z appear to be less than a straight line, so they're less than 180. But if we look at this polygon over here on the right side, while angle D, angle A, and angle C appear to be smaller than 180 degrees, the interior angle at B is much greater than 180 degrees. These two sides meet at B and go in their interior angles well beyond 180 degrees. Okay, the last term I want to get across is diagonals. Diagonals are segments that connect non-consecutive vertices. Consecutive vertices would be like P and Q. They're right next to each other. Or Q and R. Or R and S. A diagonal will connect non-consecutive vertices. So the segment from P to Q is a side, but the segment from P to R or P to S is a diagonal. The dotted lines in the figure, yes, they make a star, but they're also diagonals. Okay, let's take a look at now the definition and kind of a flow diagram which relates the four-sided polygons that we'll be studying in this chapter together. Okay, it's important that you copy this diagram into your notes. So I want this kind of a flow chart or this branch diagram indicating quadrilaterals at the top, and then below it it's connected to parallelograms, kites, and trapezoids. Directly beneath the trapezoid is isosceles trapezoid. Beneath kite is a dotted line to rhombus and a solid line to parallelogram. On the other side of parallelogram is a straight or a solid line to rectangle, and then beneath both the rectangle and rhombus I want a solid line to square. Please pause your video and take a moment to get that in your notes. Alright, what we're going to do now is go through the definition of each of these 8 quadrilaterals, or each of these 8 figures I should say. And it's really important that you learn these definitions, because later in the chapter we'll be proving that figures are rhombuses, or a figure is a rectangle, or it is a kite. If you don't know the definition, you won't be able to do that. So this is important that you make a flashcard and that you keep up with the memorizing in this chapter. We'll also be looking at the different properties of the polygons. And if you know the definition, quite often you can determine whether a property is true just from understanding its definition. Alright, so let's start off with quadrilateral. A quadrilateral is a figure like this, and it's simply a 4-sided polygon. There's nothing really special about the sides. They don't have to be the same length. They don't have to be parallel. Diagonals don't necessarily bisect each other or anything like that. So quadrilateral is a 4-sided polygon. Underneath quadrilateral, there's a general class called parallelograms. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. So no matter what I do to this figure, the sides are always going to remain parallel. So get that definition down. Parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Now, there are 3 different kinds of parallelograms. The first is a rectangle, something you're very familiar with, and that's just a parallelogram that has at least one angle. Now, I'm sure you know that all of the angles of a rectangle are right, but we're trying to memorize this definition so that when we are proving a figure is a rectangle, we don't have to go to more steps than are necessary. And because a rectangle is a parallelogram, and I know that all the opposite sides of a parallelogram are parallel, knowing one right angle in a rectangle will allow me to prove that the other angles are also right angles. Okay, so once you have this definition, let's take a look at another class of parallelogram called a rhombus. A rhombus is a parallelogram in which at least 2 consecutive sides are congruent. Now again, you may be more familiar with rhombuses and know that actually all 4 sides of a rhombus are congruent. But again, if we know it's a parallelogram and I have 2 of the sides congruent that are consecutive, it's not hard for me to end up proving that all 4 are congruent. So we're trying to memorize the least restrictive definition. Alright, so that's parallelograms, rectangles, and rhombuses. Now let's take a look at a square. Because a square is a parallelogram that is both a rhombus and a rectangle. So that means that 2 consecutive sides are congruent and it has a right angle. No matter how I move this square, the angles will remain right angles and the consecutive sides will remain congruent. Alright, now another type of quadrilateral that is not a parallelogram all the time is a kite. And a kite has a funny definition. It's a quadrilateral in which 2 distinct pairs of consecutive sides are congruent. So that means that side KI and KE are consecutive and they're congruent, but KI and IT are not congruent. But IT and TE are. So if you can have 2 pairs of consecutive sides that are not congruent, but if we were to shrink this up, and a kite can become a rhombus. So that's why there's a dotted line here, because rhombuses are very special kites that have all four sides congruent, whereas any old kite just has two of the or two pairs of consecutive sides congruent. Okay, let's now take a look at the last class of quadrilateral, which is going to be a trapezoid. And a trapezoid has exactly one pair of opposite sides parallel. So that means that TR is parallel to AP, and only those two sides. Because as soon as we try to make another pair of sides parallel, you're going to end up getting something that is a parallelogram. So a trapezoid has exactly one pair of opposite sides parallel. On the other hand, an isosceles trapezoid is a trapezoid in which the non-parallel sides, called the legs, are congruent. Pay attention to some vocabulary here. The parallel sides, I, S, and CO, are called bases. The angle down here at C and the angle at O are called lower base angles. The angle at I and the angle at S are called the upper base angles. So in an isosceles triangle, the legs are congruent, but not the bases. Okay, pause if you need to, go back, but make sure you have this figure in your notes and each of the definitions, and that you memorize these definitions. The material in this chapter gets very difficult, and it starts off with memorizing these definitions if you're going to avoid having a hard time with it. Okay, I hope this information helped you with the exercises, and we'll get a start on memorizing some of the properties when we cover section 5.5. Okay, thanks.